In this experiment, we will see how streams of particles, such as beta particles or alpha particles, are affected by being in a charged field. We will consider both electric fields and magnetic field. These are our two fields. The unit for the electric field is voltage. The unit of the magnetic field is the micro Tesla. So in the first part of this experiment, we will start with a source, which is an electron gun. So you're going to see an electron gun on this table. The electron gun shoots a stream of electrons. The electrons are beta particles. Through an electric or a magnetic field, you will be asked to change the magnitude of the magnetic field, the magnitude of the electric field as well. So that electron gun shoots a stream of electrons that passes through the field. Right now, our fields, both fields are zero. So the stream of electrons passes all the way and is collected on the phosphorescence screen. If we turn the phosphorescence screen on, we can see that there is a spot in the center of the phosphorescence screen. The phosphorescence screen is our detector, and it detects the charged particles. In this case, the charged particles here are electrons. These are beta particles. And the screen glows at the position where the particles, they impact it. So simply the dot that appears on the screen shows where electrons are going through the magnetic field or the electric field. Then we can change the magnitude of the magnetic field over here. So if we change the magnitude of the magnetic field, this is the 10th place, and thereby increasing the magnetic field, we can observe how the beam of electrons or the stream of electrons bends or moves with the changing the magnetic field. We can also change the electric field. So we can change the voltage of electrons, increase or decrease the voltage of electrons, and see how that changes the stream of electrons. So this is one thing we can do with this simulation to see how changing those two variables in there, the magnetic field and the electric field, affects the stream of electrons. In the second part of the experiment, we are going to change the electron gun to an alpha source. So we're going to go to the stock room. We are going to delete the electron gun. You have to delete the electron gun so that the alpha source appears. And then we are going to bring our alpha source into the working station. And then we're going to open the shutter so that the alpha particles can get through. They will travel through the magnetic field, and you can simply measure how changing the magnitude of the magnetic field by changing the units, the strength of the field. Both fields, electric and magnetic field, affect the stream of the alpha particles and how it moves. See, the alpha particles, these are massive. So compared to electrons, they are around like 7,000 times heavier. So the micro Tesla unit is very small, and if you increase the magnetic field, okay, you're gonna see a slight effect on the movement of the beam of the particles. So this means that you would need to apply a stronger magnetic field. So we're going to increase the unit of the magnetic field to a millitesla, so from microtesla to millitesla, and then increase the magnetic field. And now you're going to see the difference in there. Okay, the effect of increasing the magnetic field on the alpha particles, you're going to see that it is opposite to that of the beta particles. If you remember that, electrons, they move to the right, by applying a magnetic field. And the alpha particles here, if I increase the magnetic field, they are going to move to the left. We're going to do the same thing for the electric field. We're going to change the unit of the electric field in there from a volt to a kilovolt, as we mentioned, because of the size of the alpha particles. And we are going to see the effect of this change on the stream of the alpha particles and how it moves. The last part of this experiment, we are going to change the alpha source into an X-ray source. So we're going to go to the stock room. We're going to delete the alpha source. We're going to choose the laser source, bring it to the station. And then we no longer need the detector, so we're going to replace that with a video camera. The video camera will record the X-rays. Okay. And then we're going to go to the live data. We're going to turn the video camera on, and we're going to turn the laser on. The laser is automatically set on a wavelength of 20 nanometers, and in intensity, this is equivalent. This is photon per second. This represents the rate at which the photons are being emitted by the laser, and it is equivalent to the nanowatts. You don't have a possibility of changing that. So this is equivalent to nanowatt. This wavelength is within the X-ray region. So the radiation that we're monitoring right now is going to be the X-ray region of the electromagnetic spectrum. So you're going to see like a spot. It's kind of like it is. We would say it's a purple spot. It's a very light purple spot that is going to appear. This is going to represent the X-ray. So this whole thing is your X-ray. So what we're going to do is we are going to adjust the magnetic field and the electric field, and we're going to determine the effect of this adjustment, whether we're increasing or decreasing on the X-ray. So you're going to notice that X-rays, they have no charge. These are different than the beta particles and the alpha particles. And because they have no charge, when they pass through the electric field or the magnetic field, they are going to be unaffected. So, as a summary for this experiment, electrons, which are beta particles, these are the smallest particles, and these have a charge that is opposite to that of the alpha particles. So, you can easily monitor the change of the beam of the beta particles whenever they pass through an electric field or a magnetic field. As for alpha particles, the alpha particles are very big. They are massive compared to the beta particles. So this is why they require a higher magnetic field, a higher electric field, so that you can move them. As for X-rays, you can see no change because in the magnetic field and changing the magnetic field or the electric field, because X-rays, they have no charge. So they are not affected by the change of both fields. Hope this helps. If you have any questions, please let me know.